Yo, 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 this Coach Ray coming at you with the old school YouTube video here in person. It's been a while. All right, today's notes, Vertex Form. Okay, we'll get started right away. Standard form, this should be reviewed. You know that this is ax squared plus bx plus c. A, b, and c are normally numbers. 99.9% of the time, quadratic equations are written like this. You know that. Okay? What's new today is this form. Okay? We are going to switch from standard form to vertex form, and it should be no surprise. The purpose of doing that is so that we can figure out what the vertex is. The vertex is this. Hopefully you learned this in Algebra 1, 2. In a parabola, the vertex is this point right here. Very important point. Okay? So if we want to know what that point is, we can switch from standard form to vertex form, and you'll be able to see the vertex. The vertex is these two numbers, h and k. Okay? All right. Really, the only thing people mess up, I want to mention this now, is because this says minus h or negative h, it means the opposite sign of h, just like we did in quadratic formula with negative b out in front. So, for example, if this set of parentheses here says x plus 5 squared, then over here my vertex would be negative 5. It's the opposite sign of that. Because k is positive, it's just the same sign. Okay? If this said x minus 5 in here, then over here my vertex would be a 5 for h. Okay, that's one small thing that gets confused. Next thing, I wish I didn't write equals 0 here. I messed that up. This should really say y equals instead of equals 0. And the only reason is this. With quadratics, when it says equals 0, that means we're solving. And I'll teach more about that in the next set of notes. But equals 0 refers to we're about to solve. And in these problems, we are not solving. If you look at the instructions, number 1, rewrite in vertex form and identify the vertex. That's referring to the graph, not to solutions to this problem. So when we're referring to a graph, it should say f of x equals or y equals. Okay? But really it's the same thing. If it says equals 0, if it says y equals, whatever, same thing. Okay? Just know that equals 0 usually refers to solving. This usually refers to a graph. Okay. Tyson, can you scroll so this goes up? Example 1, example 2 are up.
Where's your mouse?
Perfect. Oop. All right. Oh, yeah, give me the purple right there. Don't move. Okay, purple line. Very important. In order to switch from standard form to vertex form, this is your vocabulary. We do what's called completing the square. Okay? So how you switch from standard form to vertex form is you complete the square, and that's what I'm going to show you right now. It's a very strange and odd explanation, but stay with me. I teach it weird, but it works. Okay, example 1. I'm going to start by doing this. Here's how I explain this. We hate this c. Okay, a squared plus bx minus c or plus c. We hate this guy. Okay, and I take that back. 99.9% of the time, whatever numbers are constant in the back, we hate it. So what we do is we get rid of him. We're literally like pushing him back into the corner and saying, just chill back there. You're super annoying. We don't like you. We're going to bring in a new guy right here that we love. So it's super judgy. Okay? Here's how you find the new person that you want here that you love. Look at b, the middle term, 6. Do two things to it. Cut it in half or divide by 2, so it's now 3. And square it. 3 squared is 9. I'm going to put my plus 9 right here. We love this 9 so much better than this negative 5, and you'll see why in a minute. But negative 5 sucks. That's why we moved him out the way. Positive 9, awesome. We love him. Okay? All right. But what you should be thinking is like, whoa, that's weird. You literally just changed the problem. You moved a guy out of the way because you didn't like him and completely changed the problem. You're allowed to change problems as long as you do whatever steps you need to not break the law. If I add 9 here, there's 2 ways I can avoid breaking the law. One, I could add 9 on the other side. I'm not going to do that. The other way is, if I add 9 on this side, I can also subtract 9 on this side. So it's almost like I added 0 to the left side of the equation on that scale. It's not changing the scale. Okay? So you might ask, like, all right, if you're going to add 1 and subtract it, why do you even do it? It's because it's going to change the form in the next step. But that's how we get started. All right, next thing I'm going to do. I'm going to factor this trinomial. Okay? So including my new best friend that I just invited to our group because he's awesome, I'm going to factor this trinomial. Okay? I don't always write this step out, but I will the first time we're doing it in notes. Factoring quadratics looks like this. I put x squared here. I put positive 9 here. outside here, this is probably x times x to give me x squared. I need to guess two numbers that will multiply to give me 9. I'm going to guess 3 and 3. I always tell you to guess the closest numbers. How I check them is this box would be 3 times x is 3x. This box would be 3 times x, that's 3x. Can I make 6x out of 3x and 3x? Yep, both positive. Okay, so I'm good. So x plus 3 times x plus 3 equals x squared plus 6x plus 9. Boom. I'm going to write it like this. I've got f of x equals, this is now, this front part now is x plus 3 times x plus 3. So that's this whole thing here. That just turned into x plus 3 times x plus 3. So all I have left back here is these two guys that were kind of my outcasts that I threw to the back. They're both constants, so I'm going to put them back together. Negative 5 and negative 9 is negative 14. Okay, just to be clear, this positive 9 did not disappear. It went into this box, and it's kind of hidden in here with this x plus 3 times x plus 3. Okay, let me rewrite it one more step. Let's see, f of x equals x plus 3 times itself is x plus 3 squared, and then I've got minus 14 in the back. Tyson, if you could scroll up just a little bit so that the example 1's at the top. Right there's perfect. Okay, all right. This is factored form. Okay, there's a, if you look up there in green, and you don't have to scroll, but if you look up there in green, there's an a out front. In this problem, our a was just 1, so no big deal. It's just not shown. A binomial squared, and then a constant in the back. So just quick reminder, here were the steps. We hated this guy. We moved him out the way. We put in a guy that we love. The reason we put in a guy that we love is because this always happens. If you cut this guy in half and square it, you will always end up with a binomial times itself when you factor it. So you'll always get x minus 5 squared or x plus 10 squared. This always happens when you cut in half and square. That's why we do that step. That's why I say I hate negative 5 and I love this guy, because it makes this happen right here. Okay? Your constant in the back just comes from your outcast that you threw to the back. Questions so far? Okay, vertex. It said rewrite in vertex form. Done. Identify the vertex. The vertex comes from inside here with x and my constant in the back. Since this was x minus h in the formula, I do the opposite sign, so it's going to be negative 3. And then this sign doesn't change, it's negative 14. So that's a coordinate point. That's referring to the graph. Okay, so on a graph, if I went left 3, down 14, that's where my dog's nose is. Sorry, I call it a dog's nose because I picture this looking like a dog. We probably don't need this on video, but here we go. See the dog? There's his nose. I call the dog's nose is the vertex. Okay? All right, questions? That's what we're doing, switching to vertex form. Then you can just look at it and figure out what a vertex is. All right, example 2 sucks. If you are half paying attention, now is the time to really fully pay attention. And these problems do pop up on Alex, and this will be on your test. The first thing I need to tell you will be the thing that you forget, so I'm going to try to emphasize it as much as I can. You cannot start completing the square if you have a leading coefficient. Okay? Leading coefficient is exactly what it sounds like. Coefficient meaning a number in front of a variable, leading meaning it's in front. Another word for leading coefficient in quadratics is a. If there's an a other than 1, that means we have a leading coefficient. Okay? Let me repeat. You cannot start completing the square unless a is just 1, or there's nothing written there. Okay? What everybody's going to do is they're going to move their 17 over, they're going to cut negative 12 in half and square it. Okay? But that's wrong. You have to take care of this problem in front before you get started. Here's how I take care of it. Pretty easy. I can always use greatest common factor and just factor it out. Okay, it's going to look like this. I got my y equals. I'm going to put negative 2 in front with parentheses and do greatest common factor. All right? When I factor a negative 2 out, what's left here is x squared, because negative 2 times x squared gives me negative 2x squared. No matter what that number is, doesn't matter negative, positive, doesn't matter what it is. If you have a leading coefficient and you factor it out, now you have no leading coefficient. Kind of makes sense, yes? Okay, so I have kind of solved that problem with whatever I have left inside these parentheses. All right, so let's keep going with our greatest common factor. -2 times positive 6x gives me that -12x, so opposite of distributive property. Do you foresee what makes this problem ugly now?
Yes.
Factoring a 2 out of 17 sucks. Watch, I'm going to teach you something that hopefully makes your life a lot easier. What I'm trying to figure out right now is -2 times something equals positive 17, and I really hope you're watching this. -2 times something equals positive 17. First, we know it's going to be negative, right? Okay, because negative times negative has to give me this positive. Boom, let's make it negative. Okay, and watch what's going to happen here. Okay, if I put 2 over 1 and multiply straight across, 2 times 17 is 34. 1 times 2 is 2. 34 divided by 2 is 17. This always works. Okay? You actually, like, here's another one. 2 times something equals 1,175. 1175 over 2. The reason this works is because of canceling. Your 2 on top, your 2 on the bottom cancel, so I have an answer of 1,175. Okay with that? I can do this for more stuff. Watch this. 17 times something equals 467. Seventeens would cancel, I get 467. Okay? Let me just show you easier numbers. You already do this. 2 times something equals 16. What's a something? 8, right? But in your head, what you just did was this. 16 divided by 2 is 8. Okay? So going back to this. -2 times something has to equal 17. Fine, piece of cake. -2 times negative 17 over 2. My 2's are going to cancel, right? Fine. Why did I write it over here? Because we hate him. If we hated this guy, we really hate this guy. Okay? So this is clearly not a guy we like. We're kicking him out over here. I'm leaving room to put someone I love in here. I'm also leaving room to subtract. If I add someone in here, I got to subtract him out back here, so I'm leaving room. All right, let's figure out who I love here. It is just a coincidence that both of these ended up being positive 6. I didn't mean for it to be that way. But I take my positive 6, cut it in half, I get 3. Square it, I get positive 9. Okay? If I add 9 in here, I've also got to subtract 9 back here, just so I don't break any rules. Okay, next step. I'm going to factor this trinomial. I'm not going to draw my box this time. I'm just going to do it in my head. Feel free to draw your box, but x plus 3 squared is that. And what sucks is doing -17 over 2 minus 9, so I'm going to come over here. -17 over 2 minus 9 over 1. Adding and subtracting fractions, the denominators have to be the same. So I can make this 2 by just multiplying by 2 on top and bottom. So -17 over 2 minus 18 over 2. Okay, so my denominator stays the same. -17 minus 18 is -35. All right, so what I have when I combine these two was -35 over 2. All right, I still got this -2 out front of everything, right? So I need to put another set of parentheses, keep it outside of everything. And there's one last step. It's almost in vertex form, except for this whole -2 being outside of everything. Okay? I need to distribute this back in so I can get rid of those parentheses. All right, check this out. -2 times all this crap right here. This crap is actually x squared plus 6x plus 9 all in disguise, right? So if I were to try to distribute it back in, I'd have to distribute it to all 3 things. You can't even see all 3 things here. So the point I'm trying to make is you can't distribute the -2 inside of here because this is like a big ugly thing in disguise right here. All right, so here's how I'm going to do it. -2 times that just looks like this. -2 times x plus 3 squared, piece of cake. Now negative 2 times the back guy. Oh! Negative 2 over 1 times negative 35 over 2. Negative 2 times negative 35 is negative 70. Negative 70 divided by 2 is negative 35. But also, maybe you recognize you could just cancel. 2 cancels with 2, so we get negative 35. There's my vertex form. A is negative 2. H is that. K is in the back, so let's finish it up. My vertex is opposite sign of this guy, same sign of this guy. There's vertex form. There's my vertex. This is tough. Okay, this is what you're going to have to do in your Alex assignment.
Why did you multiply it?
Good question. Get this. The question was, why did I multiply my 9 over 1 by 2? Where it was in the problem was right here. Over here, I just had negative 5 and negative 9, and I combined them to make negative 14. Here it sucked because one was a fraction, one was a whole number. So I was doing this step, and the rules of fractions are you cannot add or subtract fractions unless the denominators are the same. I can make the denominators the same. This is a 1, so if I multiply it by 2, it's going to be the same. But if I multiply the bottom by 2, I got to also multiply the top by 2. So that's where this negative 18 over 2 came from, and then I could combine it to make this. Great question. All right, that's it for your vertex form video. It's been fun. I'll see you next time. Deuces.